Hey guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question. Check if an array can be divided into pairs whose sum is divisible by k. So in this question, we have given an array, and by using the elements that are present in the array, we have to make a pairs such that the sum of that pairs is divisible by k. Okay. So for example, we have given k as a 10, and this is the array. And now we need to make a pair by using the elements that are present in the array. Okay, now for the 56, our k is 10. For the 56 can be make a pair with 44. Why? Because it is ended at 6 and 56 can be pair with 44. It that 44 is ended at 4. So if we are calculating the sum of these two numbers, 56 and 90, and sum of these two number is 100. And if we are dividing this number with k, then our it should return 0 as a remainder. Okay, 0 as a remainder. So for the 6, for the number that are ended at 6, we need another number that this number can be paired with. It should ended at 44. So 56 can be made pair with 44. For 79, we need a number that are ended with 1. So we can make a pair with 79 with 11. For 82, we can make a pair 82 with 18. We can make a pair 97 with 23, and for this also. So so for k is 10, how this type of pairs we can make. So for is k is 10, let's talk about for k is 10 what type of pairs can be possible. So if the number is ended at 2, so it can make a pair with another number that should be ended at 8. So it can be 78, 68, 18, 98. So it can be anything. Okay, so when we are talking about first number and it is ended at 2 and our k is 10, because our k is 10, we need to make sure that its sum is divisible by k and its remainder is 0. For 12, it can be make pair with 70. For let's say example 56, for 56 it can be make a pair with the number that are ended with 4. For example 55, it can be make a pair with another number that are ended with 5. For example our number is 23. So for 23, it can be make a pair with the number that are ended with 7. So it should be 28, 27 is also possible. And if we are dividing this number as by 10, so we are dividing this number by 10, it should give us a x value. X value means it should give it is given us a remainder value. So we are dividing 10 and 12 by 10. So it is given 2 as a remainder. If we are dividing 78, 10 m dividing by 78 by 10, it has giving us k minus x remainder value. That means 8 value. So for this, if we are adding these two, 10n plus 2 plus 10m plus 8, it is 10n plus 10m plus 10. So if we are dividing this number by k, it should give a return it should return us a 0 as a remainder. So what is this? X and k minus x. If our x is 2, our x is 2 and our k minus x, that means 10 minus 2 is 8, then this number needs the number its remainder is 8. This number needs this type of number that should gives the remainder value as the 8. So it can be make a pair and it should gives a 0 as a remainder value to us. Okay, now let's take example for 7. Okay, for 7, this is the 44. So if we are dividing 44 by 7, so it is 7 into 6, that is 42. 42, and if we are adding 2 into this, so it can make a 44. Okay, so for this 42 and 42 plus 2, So it gives 2 as a remainder for this. So our x is for this number is 2. So another number that it can be make a pair with, so it we need that number's remainder is k minus x. That means k is 7 and it minus x, that, so we want a number that's that remainder as a 5. Okay, remainder is 5. So 84. When we are dividing this number by 7, that means 7 into 11, that means 77 plus 5, it gives us 84. Okay, 84. Okay, it gives us 84. So at this point, 7n plus x, that x is 2, and this number is 7n 7m plus k minus x. Okay, k minus x, it gives return remainder is 5. So these two, addition of these two gives us a 7. Now let's talk about for 11. Okay, another example, if our k is 11. If our k is 11, we are dividing this number by 11. It gives 11 into 3, that is 33 plus 3. Okay, it gives us 36. So our x for this number is 3, and we want another number that this number can be paired with, that is k minus x. So k is 11 and it is x is 8. Okay, another number that gives remainder as 8, we want that number. So 85, the number is 85. When we are dividing this number as a by 11, it gives 11 into 7, that is 77 plus 8 plus 8, it gives us 5, 85 number. Okay, for this 11n plus x, the x is 3, 11n plus k minus x, that is 8. The addition of these two, that means 11n plus 11m m is plus 3 plus 8, that means 11. Okay, so these two numbers can make a pair, and when we are dividing this number by 11, it gives 0 as a remainder to us. So our k, for our k, the function k by n and plus x, for this x, and when we are dividing this by k, it should be cancelled. When we dividing this number as a k, it should be cancelled. This is the k minus x. Okay, x and k minus x, both numbers count we want as a same. Okay, now let's take this example. Okay, this example, and for finding the answer, we are using the unordered we are using the map here. Okay, map, frequency map here. So the frequency map contains remainder versus how many times the remainder are coming. Okay, when we are dividing 77 by 10, the remainder is 7 and count is 1. When we dividing this 22 by 10, the remainder will be 2 and count is 1. 56, remainder 6, count 1. 11, remainder 1, count 1. 45, remainder 1, remainder 5, count 1. 34, remainder 4, count 1. 78, remainder 8, count 1. 29, remainder 9, count 1. 23, remainder 3, count 1. 55, remainder 5 and count is 2. So for this condition, same remainder, we have two counts, that means two numbers that are same as in remainder. Okay, so this is let's take this number as the x. For k is 10, this is x, and this number can make a pair with this number. How? Let's talk about this. This is x minus, k minus x value. This is k minus x value. That means k is 10, x is 7. It gives us 3, and this is a 3. Okay, So this number can make a pair with this number, and both numbers have only one times. Both numbers are in only one times. Now this number can make a pair with this number. 2 can make a pair with 8. 6 can make a pair with 4. 1 can make a pair with 9. And 5 can make a pair with 5. That means 45 can make a pair with 55. So the count of 5 is 2. So it will appear for the 2 times. So it can make a pair with another number that's remainder is also 5. Okay, now let's talk about for 8. Okay, let's talk about for 8. So for this, when we dividing 9 by 8, then our remainder will be 1. Okay, remainder and count. Okay, remainder and count. Remainder is 1 and count is also 1. By 56, remainder will be 0, count is 1. By 25, remainder 1, count will be 2. By 52, remainder is the 4 and count is 1. By 72, 1, 2, 3, 4, 5. 72, 0 as a remainder, count increases the count. For 44, increasing 4 as a remainder and increasing the count. For 80, increasing 0 as a remainder and increasing the count by count of that zeros. We are increasing the frequency of that 0. For 36, for 4 as a remainder, increasing the count. 96, 0 and increasing the count. For 71, 7 as a remainder and count is 1. For the 55, again 7 is a remainder and count is 1, adding count. Okay, for this now our k is 8. So we are taking this number as a x and this number as a k minus x. So x is 1, k minus x is 8 minus 1, that means 7, and both have two counts, equal counts. X have count, that means f of x, and k minus x. Okay, k minus x have f dash of x. So both counts, if the both counts are equal, then we can say that both the numbers that can be pair make a pair with them together. Okay, they can make a pair with one and another. Okay, now let's talk for 0. 0. The numbers that are giving us 0, this number, again this number, 96 and 70. This number can make a pair with this number. This number can make a pair with this number. And after that, so these are some conditions. Now, if our remainder is 0, then we need a count in even part, even numbers. We need a count in even numbers. If our remainder contains 0, then we need a even number of counts. Even number of counts. Why? Because this number can make a pair with this number. That means this number can make a pair with this number. This number can make a pair with these numbers. Okay. For 4, that means for 4, our k is 8. K is 8 and 4 value, that we can say that it is k by 2. We can say that 4 is the k by 2 value. Okay. It have odd number of counts. So these two numbers can make pair with these two number with this and for this number no one is present here. So it gives false as an answer to us. So this is also one condition to have. If our k, if our remainder is k by 2, then we also want even number as a count. Okay, even number as a count. If for example it is 60, then we have 4 numbers. So we can make a pair with this and this with this. So these 3 has a condition, then that we need to take care of, that x count will be equals to k minus x count. If it is equal, then we can say that it is true. If these 3 conditions both are equal at a time, both are equal, then we can say that it is true answer. Okay, now Now let's code for it. So now we are on our ID. Let's take this to the full screen mode. Okay, let's make font clear to everyone. Now we need to make a frequency array first. So unordered unordered map of it contains int and int. So we can say that map int of int and int. That means at the first point it contains remainder, and at the second point it contains the count of that remainder, how much times the remainder have come. Okay, now we are starting with the for each loop int val with array. So it are taking the values from array, and we are finding the remainder. With that, value will be divisible by k. If our matrix our map dot find, if our map contains the remainder is equals to map dot end. If this condition is not true, if this condition is not true, then we are updating our value. That means we have already the remainder in our map. Okay, our unordered map, and we are just updating that value for this. Okay, with 1 we are updating our value with, if the our uh, 0 and our zeros count is 3, then we are updating that value plus 1. In the else part, we are updating our remainder. We are pushing, that means insert we are inserting a new value. That for that we need to make a pair, or we need to make a pair as a remainder and 1. For the first time we are saying that for the 1 we have a count is 1. So we are pushing, we are making we are inserting a value into the map, that is first value contains remainder with count 1. Now again we need to run a loop. Okay, for each loop int val array. Now we are again finding the remainder, that is value modulo by k. Okay, now first condition that we have discussed here. First condition, if our remainder is 0, then we need even number of counts. If our k divided by 2, if our k remainder is half, k is half, then we need even value. And the third condition, our x count is equal, it should be equal to the k minus x count. Okay, now for that, first condition, if our remainder is 0, then we want equal even number of even number of count. Okay, if our remainder is 0, then we are writing something. Else if our remainder is equals to k by 2, we can't write this as like this. Why? Because let's take a new page. Okay, if our k is 10, then we can say that our x is k by 2, that means 5, and our k minus x is also k by 2, that means 5. But if our uh, k is 11, then our x is k by 2, that means at somewhere at 5 or 6, and for this k minus x somewhere at 6. Okay, so this is not gives us a true value, so we are modifying that, and we are rewriting this as a 2 into remainder. 2 into remainder is equals to k. If this condition, that means we are writing for if our remainder is half of k, half of k, then also we want the even count. Okay, even count. In the last part, in the else part, if our x count x, that means our remainders count should be equals to remainder, sorry, k minus remainder count. Okay, now in the else part we are handling that condition. If our remainder is 0, then we are checking that is map of remainder modulo 2 is not equals to 0. If this condition is true, then we are printing the false answer from this point, false, and returning from this point. Why? We are, what we are checking here, is this count is even or not. We are checking that map of remainder modulo 2 is this in. If it is in even count, then it should not true. This if condition is not true, and it will go to this point. Okay, after that, for this point, this is also same, and for this point we are checking at this point is our map of remainder, is not equals to map of k minus remainder, then we are printing the false answer from this point. Copy this answer, paste it here, and for this, at this point we are printing true answer, and we are returning from this point. Okay, now let's check that insert make pair. Okay, let's check these conditions. Let's try to run this code. So it is successful. Let's try to run it for the all test cases. So all the test cases are passed here. Now let's talk about that first. So we are initializing our unordered map, and it contains the remainder versus count. Okay, we are starting with the for loop. For each loop, the value are contains array of 0, array of 1, array of 2. Okay, and we are finding the remainder, and we are checking that is our remainder is present in the unordered map or not. If it is present, then increase the count. If it is not, then initializing a new making a new pair with remainder and count as one, again for each loop, and finding the remainder. First condition is our remainder 0. If it is, then we want a even number of count. If it is not even number of count, then print false. Now at this point, we are checking is our remainder is half of k, that means k by 2. If it is, then we again want remainder in even count. So if it is not, then again we are writing a false, printing a false, and returning from this point. Now this if statement, we are checking is x count is equal to x minus k minus x count. Is x count, that means its remainder count is, if it is not equal, then we are again returning false, printing false, and returning from this point. If this three condition is not true, then we are printing the true from here, and end of the function from this point. So I hope you understand the question and the solution of this question. Thank you for watching.